Okay, let us start with question 2, and it reads as follows. Remember, you must start this question on a U page when you're writing. And the question statement says that the letters A to E in the table below represent 6 organic compounds. 6 A to E, that is a mistake, so this should be 5 organic compounds. So if you look at it, you have A, B, C, and D. So it's only 5, it's not 6. And okay, so let us see. Compound A is an alcohol. But what are alcohols? Remember, alcohols are organic molecules containing what we call a hydroxyl group. So this OH there that you see is called a hydroxyl functional group, and it is connected to an alkyl group. This is an alkyl group, but it can also be connected to an aryl group. So as we can see on this compound here shown in A, that the OH group is connected to the alkyl group, as I've mentioned. So remember, alkyl groups are nothing but functional groups that are derived from alkanes. So you see this, if instead of the OH here we had the H, this would have just been a normal alkane. Okay, and then compound A, again, the one thing we can note about compound A is that it is a tertiary alcohol. Why am I saying it is a tertiary alcohol? Remember, tertiary alcohols are alcohols where the carbon of the hydroxyl group, so this carbon of the hydroxyl group, of the hydroxyl functional group, is bonded or is connected to 3 other carbons. So okay, look at this. You have your carbon of your hydroxyl group, and then it's connected to this carbon here, and this carbon. So it's 3 carbons attached or connected to this carbon of the OH or hydroxyl group. Hence we call it a tertiary alcohol. If, for instance, this carbon of the hydroxyl group of the OH group was connected to 2 other carbons, we would call it a secondary alcohol. And if it was only connected to one other carbon, we would call it a primary alcohol. So yeah, just remember those distinctions between how to identify a primary, a secondary, and a tertiary alcohol. And then let us move on to compound B. Compound B is what we call an aldehyde. But then how do you identify an aldehyde? An aldehyde have what we call the carbonyl group. So this you see this carbon to oxygen double bond here, we call it a carbonyl functional group. So how you identify an aldehyde is that there is only one hydrogen attached to the carbonyl group. So that is how you identify an aldehyde. As you can see, we have the C and we have a double bond, carbon to oxygen bond, and then it's connected to one other hydrogen carbon there at the end. So we know that that is an aldehyde. And then let us move on. We have compound C. Compound C is an alcohol. How do we know that? So they didn't give us, in this instant, they didn't give us the structural formula. They've just written it down for us, and we can see there at the end we have that all suffix, that is characteristics of how you would normally write down the names, the IUPAC names of your alcohols. So this is how we know that this is an alcohol. And then compound D is a ketone. How do we do that? Again, looking at the suffix there, the own suffix tells us that this actually belongs to ketones. So it has it is a ketone. And then the last compound, if you look carefully, let me just go down, it's another alcohol. I'm sorry for that. So it's another alcohol. So if you start from this side here with this carbon, if you start doing from the right, and then there at the third carbon number 3, we have that hydroxyl functional group that we spoke about, and then hence that we say this is a, what we call this is an alcohol. And if we look at the carbon connected to the hydroxyl group, this OH group, we see that it is connected or bonded to 2 other atoms, to 2 other carbons, meaning that it is actually a secondary alcohol. Later in the video, we are going to draw the structural formula for this, and you'll actually note that this is a primary alcohol, and this you can see, as we've mentioned, is a secondary alcohol, and the first alcohol that we spoke about was a tertiary alcohol. And then we'll also learn about how to distinguish between aldehydes and ketones. Let me just move. And then our first task is to answer question 2.1, and it says that write down the letter that represents each of the following. So all this is just one mark, a single mark. So question 2.1 is requiring us to write down a tertiary alcohol, or the letter that represents a tertiary alcohol. Question 2.1.2, a letter that represents an aldehyde. Question 2.1.3, a letter that represents a ketone. And question 2.1.4, a letter that represents a functional isomer of compound B. So yeah, let us just try to answer question 2.1. Okay, let's start with question 2.1.1. We have to look in our table that was given in the question and write down a letter that represented a tertiary alcohol. And we already talked about the fact that the alcohol, the compound A, is actually a tertiary alcohol. So we've already spoken about how to identify between secondary, primary, and primary alcohols. So we said that if, for example, a carbon with the hydroxyl group is connected to one other carbon, perhaps here there will be an H, and then here we have a, so it's connected to one other carbon, we would call that a primary alcohol. But then if now it's actually bonded to 2 carbons, so we have a C and another carbon here, it will be a secondary alcohol. And if now it's joined to yet another carbon, then we would have a tertiary alcohol. So if you look at the structure of the compound given at A, that is your tertiary alcohol. For 2.1.2, so we have to write down the letter that represents an aldehyde, and we already mentioned that compound B is an aldehyde, and we said how you identify it is that with that carbonyl group. So this carbon to oxygen double bond, and so this is the structure that they gave us. Hydrogen, just trying to draw this as fast as I can. So this is the structure that they gave us, and we call this the carbonyl group that I spoke about. Carbonyl group. And if you look at it, it is this, there is a hydrogen bonded to this carbonyl group, so that's how you identify that it is an aldehyde there towards the end. And then okay, let's move on. So now we have to write down the letter that represents a ketone. So that ketone, we said compound D is actually a ketone. So remember, you will only just be writing letters, not anything else. So D is actually a ketone. So the answer there is D. And then because how we identified that they gave us the name, the IUPAC name for it, and they said it's butane 2-one. Okay, so I'm hoping that is clear. And then let us go to, we're going to continue talking about this ketone as well as the aldehyde in B for question 2.1.4. I'm just going to draw those structures. So question 2.1.4 requires us, so that is not in the picture, requires us to write a letter that represents a functional isomer of compound B. So we know that we have a compound B, which we are given the structural formula for, and we called that an aldehyde. Let's try naming this. So this carbonyl group will take priority, so we start numbering. We don't actually have to do that because it's an aldehyde. So the parent chain is butane because it has 4 carbons, and then the suffix when naming aldehydes is just al, so it's butanol. Okay, let us now draw this compound at D. They only gave us the name. They said it's butane to own, and we said it is a ketone. Let us actually draw the structural formula for this. The structural formula for this is, so butane, meaning that chain has 4 carbons. So 1, 2, 3. And then we know at the second carbon there must be that functional group. It's also another carbonyl functional group, the same way as in the aldehyde. And then we have H. This H is just going to try to make sure that I've actually drawn everything correctly. So now this is butanedione, this is butanol. And a question that might pop up in your mind is, how do we actually tell them apart? So for this, so this one, look at this. For the aldehyde, the functional group or that carbonyl group is attached to, on the carbon, there is attached the hydrogen. For this one here, at the carbonyl group, you will always have carbons attached on either side of it, on either side of this carbon. So instead of having the hydrogen, you have these 2 carbon atoms. So that's how you tell them apart. Let us now do something to answer this question. Let us write the what do you call this? The, I don't know why my mind cannot think right now, the molecular formula. So let's just write the molecular formula for this. So we see we have four carbons, 1, 2, 3, 4. So meaning it will be C4 to write the molecular formula. And then let us count the number of hydrogens: 1, 2, 3, 4, 5, 6, 7, 8. So H8, the number of hydrogens is just 1. So this is the molecular formula. Let us now write the molecular formula for this one. So how many carbons do we have? We have 4. Let's count the hydrogens: 1, 2, 3, 4, 5, 6, 7, 8. We have 8 hydrogens, and then a single oxygen. So what are you noticing? The structural formulas for butanol and butan-2-one are different, but their molecular formula is the same, and that is what we actually call a functional isomer. So these 2 compounds are functional isomers of each other, meaning the answer for 2.1.4, which required us to write down a letter that represented a functional isomer of compound B, would be D, and then you would get a mark. So yeah, let us now move on to question 2.2. Okay, we're given these 2 compounds here. This was compound B in the table, and this one was the compound, no, I left the OH here. This was compound E in the table. Cool. We've already shown how to write the IUPAC name for this, and we called it butanol. So aldehydes, every time you name them, you have to remember the suffix there, al at the end, and the butane comes from the fact that we actually have 4 carbons in our chain. Okay, so now our task is to now name this alcohol. So we already established that it is an alcohol, meaning So okay, let me do this properly. So the first thing I would say is for you to label, to number your carbons. And in this case, this OH group is going to take priority. So every time we label alcohols, the OH or the hydroxyl, we call it hydroxyl group, will take priority, meaning we have to start unnumbering from the right, not the left. So we have 1, 2, 3, 4, 5, 6, 7. So our chain, actually our longest chain actually has 5 carbons, no, 7 carbons. So we know that if it has 7, then it means that this is going to be a heptane. And we said that the hydroxyl group is on, we see that it's on carbon number 3, meaning it's going to be 3. And then because it's an alcohol, it has to have a suffix OL. So it's going to have heptane 3-ol. But we're not done. We can see on the 5th carbon, we have a substituent there. We have this ethyl group. We have another substituent here, another. So on carbon number 6, it is another ethyl group. And over here, we also have another substituent, which is a methyl group. So now we have to include them in our naming. So okay, we say, okay, we have 2 ethyl groups on carbon number 5 as well as carbon number 6. So we will have 5.6 di, because there's 2 of them, diethyl. And then we have a methyl group here at carbon number 6, methyl. Oh, there's an L here, 6-methyl heptane 3-ol. So that would be the name of compound E. And the marks for that, let me check. The marks for that is actually 4 marks. So, just naming, giving those IUPAC names for your compounds is important. I think we are done with this question and we can move on to question 2.3. From the table that was given, we know that compound C is actually the IUPAC name. We given the IUPAC name as butane 1-ol. So that's not an I, that's a 1. And question 2.4 says write down the structural formula of 2.4.1, a positional isomer of the compound C. So we're given this compound and we have to find its positional isomer. We've already given the definition for what a positional isomer is. So let us now just draw the structural formula for this first. So because it's butane, it means there are 4 carbons. And then on the first carbon, we have OH. Then we can just fill in the hydrogens there. And that is our structural formula for butane 1-ol. But now we have to write its positional isomer, meaning the position of this functional group of the hydroxy group must be on a different carbon. So it can either be on the first carbon or the second carbon. So let us do that. So this means that we will draw the same number of carbons, which was 4, and then on the second carbon, instead of the first, we can put the the hydroxy group, the hydroxyl group, yeah, hydroxyl. So there we are. So now if you look at these two, their structural formulas look different, but their, what do you call this, their molecular formula is the same. So let's count the number of hydrogens: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You just confirm with me, and then there's a single hydrogen. And then let's write this one for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 hydrogens and 1. So their molecular formula is the same, but structurally the positions of the functional group, in this case the hydroxyl functional group or the OH, is on different carbons. This one was on the first carbon, this one is on the second carbon. So yeah, I think we have answered question 2.4.1. The next thing that we have to do is actually draw the structural formula of compound D. We've already done this previously, but let us do it again. If you check on your table, compound D is actually that ketone that we spoke extensively about. So we have butane 2-ol, and because we said it's butane, meaning there are four. So there are four carbons. And then if we start numbering from this side, the carbonyl functional group will be on the second carbon, and then we can just have our hydrogens like that. And this is the structural formula for butane 2-ol. And then now we go to question 2.4.3, and it reads as follows. Write down the structural formula for the organic acid that will react with compound C to form butyl propanoid. Let me just remove this. So the compound C, this is the compound C. Let me draw it. It is an alcohol. It is that alcohol butane 2-ol, butane 1-ol. Let's put the hydroxyl there on the first carbon, and they saying that this alcohol is going to react with some acid, and then after it reacts with that acid, it's going to give us butyl propanoid. You know, if you remember your organic chemistry, I think it should already be clear what acid is that. So what do we call this compound? If you remember, what do you call it? Remember, this is actually an ester. This is an ester that is formed from the alcohol, which is our butane 1-ol. And when it reacts with an acid, that acid is actually going to be a carboxylic acid. So it's going to be a carboxylic acid, and then it will form this butyl propanoid, and of course during this process water will also be released. So remember this, we call this process esterification. So now how do we find what acid that is? So the butyl part of the name comes from the alcohol, and then the propanoid part of it comes from the carboxylic acid. So this is telling us, if you look at this suffix here, or if you look at this part here, propan, it is actually telling us that this carboxylic acid has 3 carbons on its chain. So okay, let's do that. So we say 1, 2, 3. So we know this -1 problem. And then because it's a carboxylic acid, we know that it has a functional group, or it has a functional group that you draw like this. So this is how you normally draw the functional group for carboxylic acid. And then you can just put on your hydrogens. So this is actually the structural formula for X. So we have found that structural formula. But what is the name? So to name what do you call this? To name carboxylic acid, we start of course with that propan, because there are 3 carbons. Propanoic. So we have propanoic acid. So meaning the answer to question 2.4.3 is that acid that reacts, therefore that acid that reacts with the alcohol here, which is our butane 1-ol, is nothing but propanoic acid. This brings us to the end of this lesson and of this question. Remember, if you don't understand anything, you can always just ask me on WhatsApp. Yeah.